This is homework 6.4. The question is, the weights of golden retriever dogs are normally distributed. Samples of weights of golden retriever dog each with n equal 15 are randomly selected, and then sample means are found. Is it correct that sample means can be treated as being from a normal distribution because the sample size is too small? Well, the answer is no, because the original retriever dogs are normally distributed. So it doesn't matter what sample size is. So the answer is it correct to treat the sample mean? Is it correct to conclude the sample means cannot be treated? No, it is wrong. No, because no, the sample means can be treated. Okay, treated as normal distribution because the golden retriever dogs are normally, because the original is normally distributed. Okay, so the answer is no, the original population is normally distributed. The sample means will be normally distributed for any size. Okay. So now, question number 2. Assume that females have birth rate that are normally just mean is 75. So in the middle, mean is 75. And then sigma is 12.5. Now, A. If one adult female is selected, find the probability that her birth rate is less than 81. So there should be somewhere here 81. So they want you to find the probability or area of here. Now, if you go all the way to the left, I said, you treat that number as negative 999,999. So you have to say normal CDF the minimum is negative 999,999. Maximum is 81. And then mu is 75. And sigma is 12.5. So in your calculator, go to second bars, normal CDF. What did I say? Low one is negative. You can just leave. You can just leave as negative 1E99. What that means here is negative 1 times 10 to the 99. Very, very big negative number. So either one, either that, or either that will work fine. So you don't have to change in your calculator. So upper should be then 81. And then mu is 75. And sigma is 12.5. and you hit enter, and if you enter one more time, you get 0.6844. Do you see that? Okay, so it is 0.6844 decimal. Okay. Now, instead of a one female, what if 25 females are randomly selected? Okay, then what will happen in the case then? In part B, you will change normal CDF here. Now, negative 999, 999, 81, 75, and what's going to change is this one, 12.5 divided by square root of 25. Okay, so in other words, mean, max, mu, and next one is sigma divided by square root of n. So if I use this calculator, second bars, normal CDF, and then negative 999, 999, comma, 81, comma, 75, comma, and then 12.5 divided by square root of 25. 25. So you gotta close parentheses, and you have to close one more time. Then you get 0.9918. 0.9918. So 0.9918. Okay. Now, why the normal population be used in part B even though sample size does not exceed 30? Because the original population is normally distributed. So let me see. Since the original population has normal distribution, the distribution of sample means is normal distribution for any sample size. Okay. If the original population is not normally distributed, then sample size has to be more than 30. Okay. Okay. This question 3 is almost similar. They just want you to practice one more time. Question 3. Overhead reach distance of adult female are normally distributed. Or mean is 200. So this is mean is 200. And standard deviation is 8.6. A. Find the probability that individual distance is greater than 210. So this is 200. So somewhere here is 210. And we need this probability. And toward the right, we assume is 999, 999. So you have to enter normal CDF of 210, 999, 999, and then 200, and then 8.6, because it's one individual, okay? So now you put that in the calculator, second bars, normal CDF, and I'm going to put 210, comma, 999. I can put as many 9 I want actually. 200, comma, 8.6. Then you get that area is 0.1225 by rounding to 4 decimal. So 0.1225. Okay. Now part B, for 20 randomly selected distances. Now, so it becomes part B. So it's going to be normal CDF. Everything is same except 999, and 200, and then the last one. Let me just write with red. The last one is 8.6 divided by how many? 20, square root of 20. That will change here. Okay, so normal CDF, I'm going to clear everything. Second bars, normal CDF, and 210, comma, 999, comma, 200, comma, 8.6 divided by square root of 20. Okay, then let me see. 210, 999, 200, 8.6 divided by square root of 20. Yes. So this is, oops, this is 9.97495 times the 10 to the negative 8. That means, let me see if I did it right. No, it is greater than 197.8 here. So it changes 197.8. So I have to graph differently for that. Here. It's not 210. So it is actually, graph goes like this. And then mean is still the same, 200. And sigma is still the same, 8.6, but they want it greater than 197. So this point is 197.80. So they want to find this probability. Okay. So now for n equal what? 20. So normal CDF, and then it is 197.80, 999, because all the way there, okay, and then 200, and then 8.6 divided by square root of 20. So the calculator, well, let me clear everything for now. Second bars, normal CDF, and then 197.8, comma, 999, comma, 200, comma, 8.6 divided by square root of 20. So it is 0.8737 by rounding. 8737, 0.8737. Okay. Now, why can the normal distribution be used even if the sample size doesn't exceed 30? Because original distribution is normally distributed. Okay. Here, the normal distribution can be used because the original population has the normal distribution. Okay, now let's do question number 4. elevator has a placard stating the maximum capacity is 3,600 pounds or 25 passengers. So 25 adult male passengers can have mean weight of 144. Assume that weights of males are normally distributed with mean of 177 and standard deviation of 40. So we have this picture. Mean is 177. Standard deviation is 40. In part A, find the probability that one randomly selected adult male has a weight greater than 144. 144. Where you get 144 from? 3,600, 25 passenger, about 144. That's where it comes from. So now, question is, what is the probability that one person, when you randomly select one person, that person weighs more than 144? So this is again normal CDF of, over here is 999, 999, 144, 999, 999, and then 177 and 40. So if you do that, second bars, normal CDF, and then 144, comma, 999, 999, comma, 177, comma, 40. Then you get 0.7953. Okay, so 0.7953. Now, what if sample of 25 passengers, okay, adult male, exceed 144? So now, it will be, this will be changed. This will change to what? 40 divided by square root of 25, which is same as 5. So everything's same, 144, 999, 999, 177, and that, and then normal CDF. Okay, for the part B. So normal CDF, and then 144, 999, 999, 177, and then 40 divided by square root of 25 is simply 5. Okay, so that is 0.9999814 like this. Okay, so they want you to 4 decimal. So if you 4 decimal, it is 1.0. Okay, so it's almost guaranteed that mean weight of 25 people will be more than greater than 144. Right? Now we have part C here. What do you conclude about safety of this elevator? Because we assume that each male weight is 144 pounds. According to this, if you have 25 passengers, their mean weight greater than 144 is almost guaranteed because probability is 1. So elevator is not safe because their weight is more than 144. Okay, so is the question, is it safe? What do you conclude about safety of it? It's not safe. No, it's not safe because 25 anesthetic people never, no, because there's a good chance, it's almost 80.999, that 25 randomly selected adult male passenger will exceed the elevator capacity. Okay, so that should be the answer. Okay, now the last question. The standard deviation of the distribution of the sample mean is this one, sigma divided by square root, and that's what we've been doing. Okay. And I think that's the last one. This is very short section.